So hello everyone, and once again welcome to our virtual brown bag seminar where researchers of the University of Oulu present their work and approach interesting topics from a multidisciplinary perspective. This seminar is brought to you by the University of Oulu Focus Institute's Research Support Services and Tellus. My name is Simo Kekäläinen, I come from Tellus, and I'll be moderating the event today. So as you know, because of the coronavirus pandemic, we're not able to organize any physical live events. And this is why in the past couple of weeks, we have been bringing many of our events to the virtual world. It's quite wonderful to see how so many of you have also found your way to virtual Tellus. In the future, you'll be seeing more brown bag seminars, interviews, morning yogas, and other interesting events taking place regularly here in virtual Tellus. You can check out the full program from Patio or from Tellus's own website. But today's brown bag seminar's theme will be energy transition. And we will be welcoming two very distinguished speakers who are Professor of Energy Systems and Environmental Engineering, Eva Pongracz from the Faculty of Technology, University of Oulu, and Research Professor Maria Kopsakangas-Savolainen from the Finnish Environment Institute and Oulu Business School. Welcome, Eva and Maria. Before we go to the presentations, let's just go through a couple of practicalities. We will first hear both presentations, and then our speakers will be taking your questions together. So if you have a question, you can either write the question in the chat box in this Zoom window, or you can also ask our hosts to open your microphones, in which case you'll be able to ask the question yourself. But that's all from me now. I think we will move forward with the seminar. Again, thank you so much for coming. Hopefully you will enjoy the seminar and the topics we will be discussing. And now I will be giving the floor to our speakers, and I think Eva will be starting.
Yes, thank you very much, Simo, for the presentation and also for the invitation to speak on this seminar and on the subject, which is very much close to the heart. I trust that you can see now my full screen, and my subject is energy transition, of course, as advertised. So firstly, I wanted to go into the issue that why energy transition, of course, our overlying and underlying motivation is mitigating climate change, which is going to require a fundamental redesign of energy systems, where ultimately we expect renewables to replace fossil fuels. But this fundamental change and the overlying change of the entire energy system is what key to energy transition. So everything from how we generate electricity, how we transmit, how we distribute, and how we use will have to change. So that is one of the key issues. And the other is the speed of the transition, which has to be quite fast. And energy policy is one of the underlying motivators, which is pushing forward this transition. But at this point, I also have to say that globally, energy or access to energy services is a fundamental human right. And it's one of the sustainable development goals that by 2030, everybody on this earth should have access to carbon free, or at least modern, reliable and sustainable energy sources. But decarbonization is one of the key themes, which is going to mean the reducing the carbon intensity. And this has been also the underlying issue of the Paris Agreement, which in 2015 was an unprecedented and the first ever universal and legally binding kind of agreement of 196 countries. Of course, we know that USA withdrew from it meanwhile, which is going to come in effect in November this year. But basically, the idea was that this is coming to force this year, that we want to achieve climate neutrality by 2050. So by the middle of the century, the emissions and the sinks will have to be balanced. This is going to be achieved by clean technologies primarily, and our motivation is preferably to keep the warming of the climate, the total warming of the climate under 1.5 degrees. And we want to do this to avoid catastrophic consequences of climate change. It's very, very ambitious, as you're going to see, and we need to revise it every now and then. It's an interesting point, what I mentioned also, that This is a global commitment, and rich countries actually even committed themselves to pay some amount of money to help developing countries to drive their own adaptation methods. Now, decarbonization, as I mentioned, is the goal. What is decarbonization? In essence, it means that we would want to generate electricity without the use of carbon. So we want to reduce the CO2 intensity of energy. As you can see from this figure, up until now, the primary energy resources, over 80% of it is still provided by fossil sources. So it's oil, coal, and natural gas. Renewables altogether, it's less than 15%. This is not only bringing us climate change, the burning of the carbon, but also other environmental impacts as well, such as heavy metals and particulates, which are particularly damaging for your health. So our primary interest in decarbonization is CO2, which is a climate forcing gas. And the issue is that if we continue burning carbon, then we have CO2 in the atmosphere. On this same note, I wanted to make a kind of detour to discuss carbon-based and non-carbon-based energy. So, of course, fossil sources, oil, gas, and coal are carbon-based. But I also have to remind that also biomass is carbon-based. So wood chips, even animal dung, and agricultural byproducts, or something that we make biofuel for, such as starches, sugars, or vegetable oils, they are also carbon-based. So when we are burning them, we are ending up with CO2 emissions. So our primary interest is the so-called non-carbon-based energy sources, such as wind, solar, hydropower, marine power sources, both tidal and wave power, geothermal, and also nuclear, which is an important part of the decarbonized energy mix. Now, in Europe, our climate and energy policy is a kind of progressive effort. It's a pathway up to 2050. We are now at the 2020 objectives, which is the famous 2020 objective. We want 20% less greenhouse gas emissions, 20% better energy efficiency, and 20% share of renewables. This is by 2030 going up to 40% greenhouse gas emission reductions, and up to 2050, 80% total greenhouse gas emissions reduction, with specific targets to each sector, of which power generation is 95% reduction of carbon emissions, which basically means that electricity will have to be practically carbon neutral by 2050. Now, considering that the first goals are this year, you may want to know, are we meeting our targets? And the short answer to that is yes. We are meeting the 2020 targets. Actually, the greenhouse gas emission reductions we have reached already in 2015. In terms of renewable energy, the tendency is that we are meeting the 20%. Energy efficiency, reducing the primary energy consumption, is not exactly there. It seems to be a reducing tendency for a long time, but then it started to go up. So there is some effort to be made, but the overall consensus is that, okay, in 2020, we are meeting our first objectives, but how about 2030 moving forward? Well, that's not necessarily looking so good anymore. In terms of renewable energy, if you follow the same tendency, maybe we are going to we definitely have to make more efforts, let's put it in this way. In terms of greenhouse gas emissions, should we follow the same tendency, then we are missing the target. So definitely more efforts has to be made. And in particular, worries energy efficiency objectives, so reducing the overall energy intensity of industries and different sectors, where we seem to be missing the target quite a lot. So a lot will have to be done from this year to achieve the 2030 objectives. But how are we moving forward? Now, moving forward, I mentioned that the speed of the transition has to be especially fast, and we can see it in this massive dip from the 2030 objective to 2050. So then we have to go really in deep dive and have to make some massive efforts to achieve our European 2050 objectives. Now, of course, this is in line with global objectives, but currently our number one priorities is firstly more renewables in electricity generation. In the 2030 objective, it translates to 57% share of renewables in the power sector. So if this was in 2015 our primary energy consumption profile, so it was based on natural gas, oil, coal, nuclear and renewables, we want to reduce the overall consumption and then increase the renewables. So this is our first option, and in particular increase the use of renewables in power generation. Our number one priority, however, should be transport, because even though the other sectors such as industry, buildings and power generation has been reducing its power intensity and its energy CO2 intensity. However, in sort of transportation, our emissions have increased. So these are our major targets. So trying to reduce our overall energy consumption, relying more power on renewables, and then the transport section in particular. Globally, the International Renewable Energy Agency has made this effort, or made this recommendation, that how globally we have to move towards the 2050 objectives. And here you can see as well that massive dip from 2020 up to 2050, how we have to reduce the carbon CO2 emissions. And each sector's buildings, transport, district heat, power, and industry has to have its contribution. The three key strategies here are energy efficiency, so reducing the overall consumption, renewable energy primarily, and also electrification, which often is going to be expressed as pre-electrification. So rather than using traditional energy sources, we are using electricity. Good news is as well that, of course, this is going to require massive investments. However, if you are investing into the right thing, it can also bring a positive and sustainable growth. The estimate is 18.6 trillion calculated in US dollars. However, the another estimate is that every dollar spent is also a dollar saved in terms of avoided investments, especially in fossil fuels, and creating such a situation, which is the adaptation and mitigation measures are going to be very expensive, especially in terms of health and environmental damage. And once again, shout out back to sustainable development, that this massive transformation, a global transformation in how we are moving, how we are living, how we are producing our goods, it expected to have this new and transformative, sustainable transformative force, which is pervasive to many other sustainable development goals as well, because it is going to stimulate sustainable growth and investments in the right forms of technologies, but also provide access to modern and clean energy services to all of the world's population. Now, where these investments are going to go, it's wind and solar primarily, especially onshore wind and rooftop photovoltaics, but also offshore winds, biomass to some degree as well, yes, biogas in particular. We are also see the importance of hydropower. In terms of hydropower, our potential to extend it significantly is not so big. However, in terms of wind and solar, the availability is really massive. Others would include, for example, marine sources I mentioned previously, tidal or wave power, concentrating solar power in some places in the earth closer to equator, and geothermal as well. So these are the types of energy generation globally that we need to invest in. So how it is going to look like in the transformation of different sectors. Now, I mentioned that electrification is one of the issues. So actually, globally, we expect a massive increase in the power need. However, 86% of this power should be generated by renewables, mainly solar and also wind power. But it also requires massive investments and massive improvements in the power system. Once again, I emphasize globally, because there is still millions of people who do not have access to power systems and modern power energy services, or even if they have access, it's not stable. So we expect a massive increase in the need of electricity And also we need to invest a lot in our power systems and the power network, the transmission network, but most of this electricity should be provided by renewables. Transport, I mentioned in particular in Europe, it's one of our critical issues that needs to reduce its carbon intensity. And here as well, the three effects are energy efficiency, so reducing the need or improving more sustainable mobility services, and biofuels, direct use of biofuels to some degree, and re-electrification. We call it re-electrification from the point of view that we reduce the need for traditional carbon-based sources, what we have been using, burning in essence to propel ourselves forward. Instead of it, we are using electricity directly, which is more efficient in terms of the energy efficiency and the output of the services and input of the primary energy. In industry, it's the same strategy, so efficiency, electrification, and direct use of renewables. Efficiency in particular, and once again, we reuse, especially for thermal processes, the potential use, current use of non-renewable fossil energy sources. So this great pile is to reduce. But some direct use of renewables, for example, solar heating, where applicable, biomass for process heating, for example, and then once again, re-electrification. So hydrogen, for example, could be one of the solutions for reducing the need of high temperature processes. But in general, currently, industry is using about 14% of renewables, and this has to increase up to 63% as well. In terms of building, we need to make massive improvements in energy efficiency by better insulating of our buildings, better use of insulating materials, low carbon and very energy efficient devices and lighting and so on and so forth, but also smart systems, smart meters and smart devices which can help consumers to reduce their end use power consumption. Renewables to be admitted directly, for example, solar heating or maybe biogas for cooking. Remember that these are global measures, and globally one of the least solved problems is cooking fuels, access to clean cooking fuels. And also due to this, we still expect a massive re-electrification of the building sector, and this is once again especially in global perspective. But even for us, if you would be using heat pumps, of course, it requires some electricity. So to some degree, it increases your electricity consumption. So hence the expression of re-electrification. But as previously mentioned, rooftop photovoltaics is probably one of those technologies we're going to be investing in a lot. So to draw together in conclusion, what you can see is energy in transition. The three key efforts is energy efficiency, so getting more services out of less input of primary energy sources. Electrification or even re-electrification, replacing traditional fuel use with electricity. And renewables, of course, these are the key components with wind and solar in particular. In terms of policy objectives, we are on track with 2020 goals, but we need to make a lot more effort to 2030. And in particular, what we see is transportation is one of the sectors where we need to make a lot of improvements to reduce its carbon intensity, and also more renewables in the power sector. Globally, achieving the 2050 climate neutral future, which is the objective of the Paris Agreement, will require massive investment, but this can be also a positive issue, as when investing in the right things at the right time can actually save money, and it is just necessary if we want to stay under 1.5 degrees objectives. But once again, have to also in conclusion mention that affordable, sustainable and reliable energy supply is crucial globally to sustainable development. And it is essentially to build such a future society where everybody has the potential of self-empowerment or self-realization. But on the other hand, the future does not just happen. We make it happen. We have to set some goals, and this is something that we have globally committed to. This is what we want to do. This is what we need to do. And we have to accept and realize that this needs system changes, massive changes in everybody's life, and integration is the key element. It's not a single technology or a single change of fuel. Everything will have to change, and the future is going to have elements of energy efficiency, renewables, nuclear, carbon capture and storage, and market instruments as well, which Maria is going to tell you more about. But as a positive note at the end, that despite this massive challenge that we are facing, we are also at the brink of a revolution in energy, so to say. And it fills me with hope to consider that if we manage to solve this massive challenge in global cooperation, maybe this could be an indication that we can solve other challenges as well. And especially if we are able to solve this challenge such that we don't forget small and poor nations as well, and they can also progress in the same way, sustainably to a sustainable future, it can be potentially a good example and also an inspiration for us globally to solve other sustainability challenges as well. Thank you very much for your attention.
Thank you so much, Eva, for this very interesting presentation. And just as you said, we will continue with Maria's presentation right away, and then we have time for questions for you both.
Right. I hope you all see my presentation. Probably somebody could give me some sign.
Yeah.
Okay, great. So first of all, thank you for inviting me to this Brownback seminar, and also thank you, Eva, for giving a very nice presentation of the general background and detailed information about these climate agreements and the trend and the goals on the global perspective. And as Eva already told you, there is a huge challenges which we are facing, but also that there is a huge potential that we could make our lives better than we are now having at this stage. Eva already slightly touched that behind this energy market transition, also in globally there is a need for great electrification, and let me now to concentrate more on this electrification. And also in my presentation, as Eva has this bigger picture, I'm going to concentrate more now on the Finnish market or Finnish type of market. So basically those infrastructures which we have in more rich and developed countries. But I'm at the end, I'm going to come back why I think that it's also quite important to concentrate to develop different types of very advanced market mechanisms and technology structures in developed countries, that we could then make also the world better for the poorer ones. But I will start to make a notification that I think that the carbon-free electricity is a key in reducing emissions and in tackling this huge climate challenge. And if we now concentrate on the Finnish case, why electrification in Finland? We know that just as Eva told you, according to this 1.5 degree target, it really requires two things which are benefiting each other. So we need to get rid of fossil emissions. So we have to get them down as quick as possible. But also we need carbon sinks. So natural things and diseases, and they need to be significantly increased if we want to keep us on that very speed track in decreasing the emissions. And here you have the figure for Finnish situation, and unfortunately there is a couple of sentences or words in Finnish, but basically what I want you to look at is that this is the emissions for the Finnish economy, and these ones which are below the zero, they are the sinks, and above they are the emissions. And this blue sector here, which has reduced quite significantly, it's the energy sector. So basically it's the heat, electricity and transportation. And those are the main issues where we have to concentrate, and also to concentrate to take care of our carbon sinks. And now if we consider that why electrification, why not something else? So if we think about possible energy sources, if we want to get rid of the fossil emissions, we cannot solve this by using or by burning coal. We cannot use by burning peat. It also provides CO2 emissions. We have to get rid of fossil fuels. So we need nuclear power. It's necessary, at least in this transition period. We need biomass, but we have this sustainability constraint, so we have to take care of our carbon sinks. Then what is left? There is hydropower, and then we have the solar and wind. And when we start to consider these ones, we know that they are main sources. Without this biomass, they are the sources to produce electricity. So electrification is the kind of way how we could increase the use of these clean energy sources. And this requires sector integration. So previously we probably have thought about that we have a heating sector, we have a transportation sector, and we have an industry sector, and of course the other electricity usage. But now we have to think out of that box, and we have to think about the sector integration, that how we could make this transition more efficiently, and co-integrate that the waste for one sector could be kind of input for another sector. So how we can do this in a Finnish type of country. So and also of course in many other countries also, but probably excluding some where the networks are not so established. So in heating sector, we are more and more concentrating on different type of heating methods which use electricity. So electric heating, we have it at some sense, but then we have a geothermal electricity, we have energy, heat pumps, different type of hybrid solutions, but typically heat pumps and geothermal energy, they also need electricity to produce. What about those district heating networks, which are in quite dominant position in Finland? They should be open for industrial heat pumps, so that and these the heat pumps, the electricity which the heat pumps are using, they should be produced by clean energy, such as windmills, for example. Then we have to have different type of heat storages, so that we could more like we are more able to handle the variation of this production. Then of course environmental and waste heat should be utilized. There is a lot of unutilized heat sources nowadays. And then probably at least during some period, we need some kind of adjustable CHP plants and boilers which are run by biofuels, which act as a peak and backup power. And I agree totally with Eva that the transportation is a very important issue. Probably the heating sector and the electricity usage sector, they are more easily solved than the transportation. But it's key that the transportation is becoming less and less emission producing. So passenger transport in Finland, we have some targets for the electrification for the vehicles. And also we have targets on the biogas in this transition phase. There we should integrate this electrification of the transportation such that it's integrated in a two-way interaction to these electricity networks, so that as the variable productions such as wind and solar power increases into the system, these electric vehicles could be integrated and used also as a batteries in the electric system. Well, probably the passenger transport is the easiest sector, but then there is a heavy traffic and air traffic and ships. And in transition phase, I think that's partly electricity, but then also bio-based fuels and also some conventional fuels has to be used there. But target should be electricity and clean synthetic fuels, which are produced with the clean energy. And then industrial processes, maybe they are the kind of the last one at this stage, which are kind of ready for the market-based solutions. There is a very, very good technological innovations going on, but they are still quite expensive. But as we know, there can be radical changes and the cost can be decreased very quickly. But if we talk about how this electrification is shown into the market, so we should think about this totally different than before, because we have used to think about that we consume some amount of electricity, and then there is some factories, energy production units, and there's humans who make the decisions that now we increase the production as the demand is increased. But now as we turn to the system which is relying much more on these nature-based variable energy sources such as wind power and solar power, these are the kind of changes that we cannot handle that in that sense. We cannot decide when the sun is shining or when there is winding. So we have to think about the other way around, that we are changing from the demand-driven system to the production-driven system. And in that kind of system, there is challenges. So we should respond to variability. I'm going to talk about this one in the next slide a little bit more. We should find market-based solutions. Eva told that there is a huge investments coming. And of course, there is issues that how these investments are done efficiently, and also how then they are done such that there is no certain groups or countries who are damaged by this investments, so that there is an even larger gap between the poor and rich ones. And then there is different needs for responding to the information and probably generating new type of communalities. There is of course many opportunities also, clear business opportunities. We could increase our welfare, both economically but also welfare like like getting rid of different types of small particles in the air. So the air quality we have already now heard about during this COVID-19, that there is a certain areas in the world or the big cities which have now seen the clear sky, and of course there can be that kind of positive effects also. But let's look at quickly about this, how we could think about and how we should take into account this variability of this future and already now this happening energy transition, which is happening from this traditional burned based electricity sources to these clean energy sources. And maybe the main difference between these ones is the variability. So I already touched this problem a little bit, but basically when we burn something, we can decide when we burn it. But when we take the energy from the nature, we cannot decide when the wind is blowing or when the sun is shining. Of course, we can make some kind of prognosis, but we cannot decide that exactly at this moment we have to have this amount of energy. And if we think about electricity, it's in that sense it's not a typical commodity, because if you buy a shirt from the shop, they can produce and it can be in the storage. But if you are and then you can go to the shop and buy it. But if you are using electricity, and we are looking at the electricity networks, the consumption and production has to be equal at all time. So there is a clear challenges when now we cannot decide the amount of production. Of course, we could also there increase the capacities of different type of storages, but we know that they are still quite expensive. But basically, production varies strongly from time to time, and as an economist, I could say that the electricity is no longer a homogeneous product, because if you think about that, you are taking electricity from your block, and at this moment, if it's produced by using, for example, peat, the CO2 content is at this hour, it is something. And then in the next hour, if it's that kind of hour that the wind is blowing, and probably now the electricity is mainly produced by wind power, now the CO2 content is much lower. So basically they are not the same product, even though we use it at the same way. And of course, this is something which should be taken into account when we are pricing these products. Is this a relevant question in Finland right now? So is the wind power still in a margin? No, it is not anymore in the margin. If we look at the wind power in Finland, we have now in the market, we have a little bit over 2,000 megawatts at the end of 2019. The production was a little bit over 6 terawatt hours, which is actually now 9% from the total electricity production in Finland. And what is quite interesting is that in last year, all new investments in wind power were market-based. So they were not having any subsidies anymore. So now the costs for investing to wind power has become that low that they don't need any more government subsidies, but they can survive by themselves. But what we have in preparation, so last year we had our total consumption in Finland was around 87 terawatt hours. And now if we look at that, what projects are in preparation in Finland? So what are in some sense at the process? They have applied the permission. So there is 18,500 megawatts, from which offshore is so on the sea is 2,700, and the rest is onshore. And if you, for example, consider the Olkiluoto 3, which is under construction, the nuclear power station, it's 1,600 megawatts. So this is not any minor issue anymore. And this, if all of these ones are really to be constructed, they could produce 56 terawatt hours. So it's quite huge amount. I assume that all of those are not built, but I think that over half are going to be built in a quite near future. So the transition to this variable production is going to be quite quick. So if we now consider how we could respond to this challenge in the Nordic power market, we could think about that we have now these three dimensions on which the production is dependent. So this variable production, it is the time. We talk about the storage constraints. So we talk about that when the production is happening, the location, where the production is happening. Basically, as you see there, the most of the production is going to be in the coast and not that much and the center, for example, around the Helsinki area where the most consumption is. So we need transmission capacities, and then there is this lead time, so the flexibility constraint, and how quickly we could, if the wind is dropping down very quickly, how quickly we can put something on instead, so that we don't have any breakouts in the electricity. And here we could, for example, use new type of forecasts, so energy weather forecasts, to make it more clear that at what moment we have a production and what moment we don't have. This is the energy weather forecast, which is done in the BCDC project, and I just to get the prognosis yesterday for the Oulu and for the Helsinki, and you see there you can go to the pages and look at this forecast, and you can see there the solar and the wind power prognosis for the next 24 hours, right? But then, because of this variability, also the consumption is going to be time dependent. And in a power market in the Nordic countries, we have a solution for this variability, which is this kind of double flexibility. So that here is the demand curve, and here we have the wind power. And this is assumption is 20% of wind for the market demand. So we know that now in Nordic power market, we could quite much to substitute this wind power production by utilizing hydropower production. So when it's not winding, we use more hydro. But we know that there is a limitations in the hydropower, and now we also need to tackle this problem by increasing the flexibility of the demand. So we have to also now start to change demand curve, so that when we establish more and more wind there, also the demand has to be correlated with the wind power, such that we decrease demand when the wind is not blowing and increase it when there is a lot of wind. And of course this has to be done automatically, so this load control, that we don't actually need to think about that consumption that much. There is this is my slide, last slide, and there is just some calculations what we have done that how this wind value is changing with the demand side flexibility, and assuming that we also use this double flexibility option, that we also utilize smartly this hydro production. So here we have a so-called wind value factor, which means that it tells you that how valuable 1 megawatt hour of wind is when it's compared to the some source of energy which is totally sure that we know that we can produce that much. So basically, the higher it is, the wind value factor, the better it is. And here you have the wind share of the total system. And we see that if we don't do nothing, so basically here we have these different colors. So they are the amount of this consumption, which is under some kind of load control, so that we decrease the consumption and we increase the consumption automatically. But in that sense that for example, you don't have any power breakouts, but you just for example diminish a little bit the temperature in the rooms. And we see that the higher is the amount of this load control, it is more and more important as the amount of wind share in the market is increasing. And now here we have the share from 10% to the 20%. We are around here now in a Finnish system. But as the conclusions, I could say that I would like to connect these ones to this Eva's presentation, that in Finland and in Northern countries, we have extremely good technology possibilities to test different things. We have smart meters in every house. We have good infrastructure. We have a lot of micro-level data to design and test different types of market mechanisms. And then we could make new services, ICT products, which we could then export to the other countries, and then we could benefit the Finnish economy, but also we can help to solve these global huge challenges of this climate change issue. Thank you. Sorry, it was a little bit long.
No problem, Maria. Thank you for this absolutely fascinating talk, and also thanks to Eva. I think the presentations were absolutely electrifying. And at this moment, I'm welcoming questions. We have about 10 minutes left for discussion. So viewers, you can either write down your questions on the chat box, or you should be able to also open your mics, so you can ask the question for yourself if you want to. And now it's time for questions. Nothing coming up yet. People might
Totally silence.
writing still, but maybe we could start up with a little warm-up question. So I think the coronavirus situation is in everybody's mind right now, and you were both talking a lot about future investments, how investment should be directed towards renewable energies and different kind of new intelligent systems. What is your take on how the coronavirus situation will be affecting these investments? Is it going to be like a push factor that companies and societies will be investing into the new energy forms, or is it like a pullback factor? We retreat back to using fossil fuels and so on. What are your thoughts about this?
Well, I can start.
Mm-hmm.
I think that, of course, this is a question that we are going to see the total effect, because I think that there's a contradictory things. On the one hand, now there is a clear economic difficulties for countries, and there is of course the threat that this money which was targeted to solve these climate change issues is now directed to somewhere else, for example, to solve the employment issues and like that. So it's a one clear threat. But then on the other hand, we have now experiences what could happen if the worst scenario of this climate change happens. So this can be our new normal after if we are ending up to the situation that we really have this tremendous problems of the climate change. It could be that we have to be at home. We cannot travel. All airplanes are staying down if we don't try to solve this like wisely. So probably this can give also the signal that is this the future we really want to?
Very interesting.
Yes, I can add also on the similar vein that, well, firstly, we have made the political commitment to do this climate change mitigation in particular in Europe. So we cannot back up from that. And as Maria outlined, what I can see, it increased our awareness of the importance of critical infrastructure, such as the power network or the heating network, and well, also water, waste management, wastewater issues, and information security. We also these issues. So maybe it enforces the need that we have to make more investments to improve the resilience of these systems and the reliability of these systems. And this can go hand in hand with the projected cost. And as Maria put out, doing nothing is going to cost us more at the end, for sure.
Exactly. So we need to keep the wheels rolling.
Yes.
We had a couple of questions in the chat, and I'm going to take the first one from Arva Benkerov. She's asking if the increase in human population in future has an effect in energy consumption, meaning that, of course, when population grows, there's a need to build new cities, and the process of creating new cities is energy consuming. Are there any studied solutions regarding this growing population matter?
Yes, definitely it's going to increase. So the issue is that the situation is going to get worse before it gets better in terms of energy consumption, especially talking that there is a massive lack of infrastructure in many countries. There are millions who are living without any access to primary services or living in slums in many of the cities, or as I mentioned, have no access to primary energy services. So the most of the infrastructures will still have to be built. So it is going to require materials and energy. However, as I already mentioned, that maybe they could happen some technology leapfrogging, so they could avoid these polluting phases, what we have done in the industrialized countries, and utilize directly the more efficient and more smarter solutions. But in terms of the energy consumption, especially from the cities, the situation is going to get worse before it gets a little bit better, before all of the efficiency measures. But as I indicated, the electricity need is going to increase massively globally. However, we still expect it to be generated by renewables to a large degree. Yeah. And what else? Something else, but I forgot.
Maria, did you want to say something?
Well, just a minor comment that I agree totally with the Eva, and it's interesting to see that does the same thing happen as with the mobile phones, that in some areas globally they kind of jumped over this what is this line phones.
Yeah.
They just jumped from this no phone to this cell phones. So probably there can be some areas where they, as Eva told, they jump directly to this some kind of distributed renewable based energy systems, and
Most likely what we can see that in these countries which do not yet have electrification, it's going to be more of a bottom-up system. So starts with kind of small home solar, solar home systems as they are called, and then those are going to be added into this microgrid or grids and then collected, rather than top-down as we are doing in Europe. We have to first renovate the entire transmission network and then going down. So it is going to be a more bottom-up solution probably.
A continuation question from Arva is, are these small and poor nations which you mentioned and who need access and support for future sustainable solutions, are they identified? So you can name the countries that are especially in need of these solutions.
Probably many. First thing that comes to mind, I was doing some collaboration with Vietnam, for example. So these countries are making sort of applications for these different funding. For each country have to make their own strategies, and we are talking especially about the so-called lower developed countries. So the lower developed countries. So, but they are several, yes, unfortunately.
Okay, but as you said, the situation is going to be calmer before the storm comes, but getting better all the way. Maria, a question for you. Have you faced any resistance or enthusiasm from the company or state side in the transition to demand-driven system, or how has it been received?
Yeah, actually from the production-driven system, yes, there are parties, as often there is, that are supporting the view, and there are parties which are thinking that, or they are believing that it is not going to happen. And of course, I understand that in Finland, for example, we have a different areas where for example, in Oulu area, we have a quite lot of peat production, and there is people who are dependent on that one. And we have to make this transition wisely so that there is no certain groups that are going to be more vulnerable to these ones, that the others maybe direct some kind of support for these ones. And also the same applies for the politicians. But I've been quite happy to see that just during the couple of last years, there has been a clear change in the atmosphere, that more and more people are supporting this kind of transition, and they understand that we have to make this change, that actually we don't have much of the different opportunities. And also, if you think about the energy industry as a whole, so the kind of front organization of the energy industry, as their CEO said last year, that in this Finnish climate target of 2035 to be climate neutral, energy industry is not the one from which is going to be or which is going to be the one party who is not solving this one. So they are themselves, they are kind of in this change.
But in just conclusion, failure is not an option.
Yeah.
Let's put it this way. We are too big to fail, and the power system in particular, they have to be part of the solution rather than be a cause of the problem for the future.
That's a very, very good conclusion, as the time is actually running out. So we had a really great discussion, and I still want to thank Eva and Maria for your wonderful presentations. Thank you so much for coming. And of course, a thank you to all our viewers. And before you go, for the English speakers, I just want to advertise that our next Brownback seminar will happen on Thursday, the 14th of May, and we will be talking more about women's health. And in Finnish, tänään kello 13 vielä täällä virtuaalitelluksessa suomenkielinen tapahtuma Kestävä kehitys X korona kello 13. Ja siellä sitten puhutaan enemmän kestävästä kulutuksesta sillä teemalla, niin kannattaa tulla sinnekin kuuntelemaan sitten, niin tämä teema vielä jatkuu. Thank you so much everybody, and I'll be seeing you again here in Virtual Tellus. Stay healthy.
Thank you.
Thank you very much. Thank you very much.
Bye-bye.
Yeah, bye-bye.